Okay, so you punya lecture kat mana dah? Yang last week. Rules of variance dah masuk ke?
Dah, madam.
Dah sampai example berapa?
Example 41.
41.
Example 41. Okay, so ni lah example 41. Okay, so you can refer to example 41. Okay. Okay, so kalau hari ni saya tahu okay tak internet sebab tadi kelas saya pagi tadi dia macam ada problem sikit bila saya masuk Gmeet ni. So nanti kalau ada problem contoh dia jadi lag ke ataupun you tak nampak saya punya screen ke, nanti bagi tahu ya. Okay. So ni example 41. Okay. So harap okay lah. Okay, so for example 41. Okay, so ini Chinese example. Okay, so you are given a continuous random variable x with the probability density function. Okay, so you are given two functions. So sebelum ni kita involve yang one function for variance ni. So ini example ni bagi in terms of two function. Okay, so interval we have 0 until 3, another one we have from 3 until 4. Okay, so for A, we need to find mean of x. Okay, so mean of x means that we need to find the EX. Okay, so to find EX, so you kena refer balik lah formula for EX. Okay. Okay, so formula for EX for probability density function or for continuous random variables, we have limit, integrations, and x times with the fx dx. Okay, so equal to, okay, first function we have from 0 until 3. Okay, so first function 0 until 3. And we have x multiply with the function. So the first function is 2 over 7. Okay, dx. So we need to plus with the second interval. We have 3 until 4 and x times with the fx. 2 over 7 times with 4 minus x dx. Okay, so ni yang you punya general formula. Tapi kalau ada two function, maknanya you kena plus lah the two function. So you apply balik formula yang sama, x times with the fx. For example, you have three function. So kalau three function, maknanya you kena plus lagi satu lah. Plus, so yang the third function. Also, you apply the same formula, x times with the fx. Okay, so you continue. Okay, you expand. Okay, 0 until 3. You have 2 over 7x dx plus with limit 3 until 4, and we have 2 over 7 4x minus with x squared dx. Okay, so equal to you integrate So integrate x, we have x square over 2 and 0 until 3 plus with 2 over 7, and integrate for x, we have 4x2 over 2 minus with x3 over 3 and limit 3 until 4. Okay, so nanti you proceed lah. You substitute the lower and upper limit and you get the final answer is equal to 37 over with 21. Okay, so ini value for the EX or value for the mean. Okay, next for B. B we need to find so B we need to find the variance. Okay, so B to find the variance. So you refer balik formula for variance. So variance is equal to EX square minus with the EX. So you need to square. Okay, so EX you already calculate in A. Okay, so you need to find EX square. Okay, so saya calculate dulu EX square. So EX square equal to X square times with the Fx dx. So dia sama formula macam EX tadi. Tapi kalau EX, you multiply with X. For X square, you multiply with the X square. Okay, so function sama je lah. Okay, so equal to, first you substitute the limit from 0 until 3 and x square times with the fx, yang first function you have 2 over 7. Okay, and plus with second function limit 3 until 4 and x square times with the fx. So fx is 2 over 7, 4 minus x. Okay, so equal to, ni expand, okay, 0 until 3, you have 2 over 7 x square. Okay, plus with limit 3 until 4, okay, you have 2 over 7, 4x square minus with x cube dx. Okay, so nanti you integrate, you have 2 over 7, integrate x square, x cube over 3, and 0 until 3. So plus with 2 over 7, integrate 4x cube over 3 minus with x4 over 4 and limit 3 until 4. Okay, so nanti boleh proceed, you substitute limit and final answer is equal to, final answer for EX square, you ada 25 over 6. Okay, so ini for EX square. So after we have EX square and EX, then you can calculate for the variance. Okay. So for variance, we have EX square minus with EX. Okay, so you need to square. Okay, so substitute yang dah calculate tadi. EX square tadi kita dapat 25 over 6 minus with EX. So EX answers from A, mean of X. So tadi kita dah calculate mean of x is equal to 37 over 21 square. Okay, and equal to 1.0624. Okay, so ini for variance. Okay, next for C. Okay, C we need to find the variance 7 minus 2x. Okay, so saya biasa prefer yang variables x tu you letak dekat depan. So equal to variance negative 2x plus 7. So nanti you nak apply you punya rules for variance. Ni saya apply rules je. So kalau you refer rules for variance, dia also equal to negative 2, you need to square. So multiply with the variance x plus with variance 7. Okay, so equal to negative 2 square. So negative 2 mesti sekali dengan square tu mesti sekali dengan negatif. So you have 4 times with the variance x. So variance x substitute 1.0624. So plus with 0. Okay, and you get the answer is equal to 4.2496. Okay, so ini answers for C. And last for D. Okay, D we need to find 2 plus. Okay, so for D, so D sebab kat sini. Okay, so for D we need to find the variance 2 plus 5x. So 2 plus 5x, so macam biasa saya letak 5 tu kat depan. So 5x plus with 2. Okay, so the equal to 5 square times with the variance x plus with the variance 2. Okay, so 5 square is also equal to 25 and you multiply with the variance x 1.0624. So plus with 0. Okay, and you get the answer is equal to 26.56. Okay, so ini answers for CN. Okay, next we have last example. For example 42. Try me example 42. Okay. So you can refer to example 42. So x and y are independent variables such that ex square is equal to 10, ey square is equal to 20, variance x is equal to 5 and variance y is equal to 6. Okay, so we need to find E5x plus 3y. Okay, so to find E5x 3y, you can apply rules for expected value. So kalau you refer rules dia also equal to 5ex plus with 3ey. Okay, so you need to have value for ex and also value for ey. Okay, so sekarang value for ex and ey ni dia tak bagi. So you need to calculate based on the values of ex square and value of the variance x. Nanti kita boleh calculate ex. Okay, so you refer formula for variance. Variance x is equal to ex square minus with ex. Okay, so variance x given 5 equal to ex square is 10 minus with ex. Okay, so you can find ex is equal to 5 and ex is equal to 2.236. Okay, so ni for ex. Next, you can find for ey. Okay, so ey, you use formula for variance y. So variance y is equal to ey square minus with ey. Okay, so variance y is 6 equal to ey square is 20 minus with ey square. Okay, so you can calculate for ey. Okay, so you have ey square is equal to 14 and ey is equal to 3.742. Okay, so you dah ada ex and ey. Okay, next you can substitute lah in A. Okay, so from A we have, okay, so A kita nak calculate for E 5x plus with 3y. Okay, so equal to 5ex plus with 3ey. Okay, so you have 5ex, substitute yang kita calculate tadi. Ex is equal to 2.236 plus with 3 and EY is equal to 3.742. Okay, and you have the final answer is equal to 22.406. Okay, so ni untuk yang A. Next for B. So B we need to calculate. Okay, so B we have variance 5x plus with 3y. Okay, so ni pun you boleh apply rules for variance. Dia also equal to 5 square variance x plus with 3 square variance y. Okay, so untuk variance rules dia semua yang coefficient for variables tu, you ada 5 dengan 3 ni, both you need to square kan. Okay, so you can dapat 25 times with the variance x. So variance x is already given to you. You have 5 plus with 3 square, 9, and variance y is equal to 6. Okay, and final answer is 179. Okay, so ini for example 42. Okay, ada soalan tak? Kita dah habis chapter 7 ni. Tak ada soalan
Ada, madam.
Ada. Okay. So chapter 7 ni saya rasa mungkin yang susah sikit yang part depan tu je, yang dia bagi dalam bentuk application, ni kena buat tree diagram. Tapi dah bahagian belakang ni expectation ni dengan variance, saya rasa dia senang sikit lah. Okay, cuma you kena hafal formula je. Formula dengan rules dia. Okay. So next chapter saya chapter 8. So ni you punya last chapter. So chapter 8 ni still on statistic. Okay. Okay, so chapter 8, special probability distribution. Okay, so linear outcomes. First, you need to identify the discrete probability distribution. We have binomial and Poisson distribution. Number 2, calculate the probability, expected value and variance of binomial and Poisson distribution. And number 3, use the Poisson distribution as the approximation for the binomial distribution. So the first 3 linear outcomes ni refer to the discrete probability distribution. So discrete kita ada 2 lah, binomial and Poisson distribution. Okay, for number 4, identify the continuous. So ni dah masuk continuous. Okay, so linear outcomes number 4, identify the continuous probability distribution. Okay, normal distribution. And last is calculate the probabilities of standard normal distribution and any normal distribution using standard normal table. Okay, so ni kita punya linear outcomes dia. So first for discrete probability distribution. Okay, yang first distribution we have binomial. Okay, so binomial karakteristik dia mesti ada 2 possible outcomes dia. We have success or failure. So probability of success is equal to P and probability for failure we have 1 minus P. Okay, so example for discrete ni, dia mesti ada 2 je outcomes dia. Contoh you tossing a coin. So tossing a coin you ada head and tail. Okay, or you contoh you taking a test. Okay, so kalau test you ada pass or fail. Okay, dia mesti ada 2 possibilities. Tapi kalau contoh you have weight, contoh you nak measure weight. So measure weight, contoh kita ada 3 outcomes. You ada overweight, okay, you ada normal and underweight. So kalau you ada 3 possible outcomes ni, so kat sini kita dah tak consider as binomial. So binomial tu condition dia only 2 outcomes je. Okay. Next kita ada conditions. So conditions of the binomial experiment. So the first condition, the experiment consists of an identical trial. So identical trial maknanya semua you, kalau contoh you ada 10 trials ataupun you tossing a coin tu, you buat tossing a coin tu contoh 10 times. So kalau 10 times maknanya each trial tu dia mesti pakai coin yang sama lah. You tak boleh tukar pula. Okay, dia mesti identical trials dia. Okay, lepas tu each trial has only 2 possible outcomes. Macam tadi lah, dia mesti ada 2 possible, jadi tak boleh more than 2. Okay, lepas tu for number 3, the probability of success must remain the same for each trial. Contoh dia kalau you pass yang taking test tadi, contoh you ada pass and fail. So example pass dia probability you ada 2/3. Fail is 1/3. Okay, ni untuk first you ambil test. Untuk second, probability dia mesti sama. Okay, so dia mesti pass 2/3 and fail must be 1/3. Kalau you ambil until 3 pun, dia mesti probability dia sama. Baru you boleh consider as binomial distribution. Okay, dia tak boleh jadi yang macam reduce tu. Okay, so kalau you pun probability dia berubah, then dia akan jadi not binomial distribution lah. Lepas tu number 4, the trials are independent. Contoh dia macam ni lah. Okay, so dia tak boleh dependent. Dia mesti for independent event je. Okay, so the outcomes of the one trial does not affect the outcome of any other trials. Okay, so ni conditions for the binomial experiment. Okay, so biasanya binomial ni kalau dia you punya N tu dia lebih daripada 3 lah. Contoh kalau you buat tree diagram. Tree diagram kalau trial you sampai 3, then kita boleh consider lagi lah buat tree diagram. Tapi contoh you tossing a coin. You tossing a coin tu contoh 10 times. So takkan you nak buat tree diagram sampai 10 kali kan? So tree diagram tu paling banyak sampai 3 macam ni lah. Tu kita acceptable lagi. Tapi kalau more than 3 ataupun you ada 10, you ada 20 times, so semua tu nanti kita boleh pakai binomial distribution. So tak perlu buat tree diagram. Okay, so yang ni example of the trials. Okay, where binomial experiment could be used. Okay, so untuk yang first, throwing a dice. Okay, success dia example dia nak score of 1. So failure score of not 1. Okay, gender, you are the male and female. And tossing a coin, we have head and tail. So kalau tengok kat sini semua dia punya outcomes dia ada 2 je. Okay, dia tak boleh more than 2 outcomes. Okay, next we have the distribution, probability distribution function. Okay, so yang ni is the binomial formula for the calculation of the probability using binomial distribution. So you kena hafal lah ini. Okay, and N refer to number of the trials, and X refer to you punya X ni berapa, value of X, and P is probability of the success, and Q is probability of the failure. Okay, so you punya P tu probability of the success tu dia refer pada you punya X ya. Dia bukan yang bila you kata success tu dia semua yang benda yang positif. Dia tak semestinya. Dia boleh kalau X tu dia refer to number of unsuccessful. Contoh unsuccessful application. You nak apply kerja kan. So number of unsuccessful application. So dia boleh jadi P tu dia refer to the probability yang ni lah. So you punya yang unsuccess tu. Sama juga kalau X tu refer to number of undefective. So dia boleh jadi number of undefective. Okay, so number of undefective maknanya you punya P tu dia refer to you punya probability of number of undefective tu. Okay, so next kita ada, lepas tu kita ada X dia. Okay, so X tu you punya value for X dia must be 0 until N. Okay, so N tu refer to your trials ni. Okay, And the binomial distribution can written as X distribute with the binomial and P. So ni pun you kena tahu juga. Okay. For example 1. Okay, so you are given X distribute with binomial 10 and 0.28. So you have binomial 10, 0.28. So kalau you compare with the general form for the binomial, kita ada binomial NP. Okay, so means that you have N is equal to 10, P is equal to 0.28, and you need to calculate what is the Q. Q is 1 minus P. So 1 minus 0.28. Okay, so equal to 0.72. Okay, so yang ini for yang A. Okay, A kita nak calculate probability X is equal to 2. So you will refer balik formula for the binomial. We have equal to NCX. You have PX times with Q and minus X. Okay, so X equal to 2 equal to NCX, and that is 10 C2, and P is 0.28, and to the power of X, X day is 2. And we have Q is 0.72, and N minus X. So N tadi kita ada 10 minus with the 2. So you have 8. Okay, so ni boleh calculate using calculator. And we have the answer is equal to 0.2548. Okay, so ni answers for A. Okay, kalau untuk B, dia nak probability of X less than 6 but greater and equal to 4. Okay, so dia nak X less than 6, greater and equal to 4. Okay, so probability dia maknanya dia nak probability X equal to 4 plus with probability X equal to 5. So 6 not include sebab dia nak less than 6. Nanti you kena repeat balik, substitute balik you dalam you punya formula for binomial ni. Okay, so nanti akan dapat answers dia equal to 0.2637. 0.2637. Okay, so kalau untuk yang C dia nak probability of X tu, okay, so kalau probability of, so C dia nak probability of X greater and equal to 2. Okay, so maknanya dia nak probability X equal to 2 plus probability X is equal to 3 until X is equal to 10. So dia sampai X equal to 10 sebab refer you punya N. Okay, N dia sampai 10, so you probability pun sampai 10 lah. Okay, tapi kalau you nak calculate from 2 until 10 ni dia banyak you kena calculate. So nak senang you beri minus je. So you ada 1 ni maknanya total probability, minuskan dengan probability yang you tak nak. Okay, so yang dia tak nak maknanya 0 and 1. Okay, sebab kita nak start from 2 je. Okay, so you minus probability X equal to 0 minus with probability X equal to 1. Lepas tu substitute dalam equation, dalam formula for binomial, and final answer is 0.817. Okay, so ini for example 1. Ini senang je sebab dia terus bagi direct you punya binomial distribution ni. Tapi kalau you refer example 2, so example 2 ni dia bagi in terms of application. Okay, so dia kata survey found that 60% of the students use software application. Okay, so if sample of 6 students is selected at random, find the probability that exactly half of them use software application. Okay, first you kena state dulu what is the X. Apa yang you punya random variable. Sama macam chapter 7. You kena state dulu what is the X. So X sekarang dia refer to the number of students use software application yang ni. Students use software application. So you punya probability 60 ni refer to you punya X. Okay, so P dia is 60% or 0.6 and Q is 0.4. So dia nak exactly half. Half maknanya X is equal to 3. Okay, so X equal to 3, substitute dalam you punya formula for binomial and you get the answer. Kalau untuk B, dia nak at least 1. So kalau at least 1, probability. Okay, so kalau B, at least 1. So probability of X greater and equal to 1. Dia nak sekurang-kurangnya 1. Okay, so dia akan start from probability X is equal to 1 plus with probability X is equal to 2 until probability X is equal to 6. Okay, sebab N you 6 ya. Okay, or you can calculate use 1 minus probability X is equal to 0. Ni lagi senang lah, lagi simple. Okay, tak perlu you calculate sampai 5 values, 1 until 6. Okay, so kita ada or lah. Or you boleh 1 minus with probability X equal to 0. Okay, so nanti substitute lah. Substitute and dia is 6C0. So P tadi 0.6, you have 0 and Q is 0.4 and 6 minus 0. So you have 6. Okay, and answers is 0.9959. Okay, so ini answers for B. Untuk yang C, all of them do not use. So kalau do not use, maknanya probability X is equal to 0. So you calculate probability X equal to 0, sama macam ni tadi, you calculate probability and you have the answer is 0.0041. Okay, so example 1 and 2 ni actually ada dalam recorded video, so you will refer juga recorded video. Okay, so saya nak masuk expectation and variance of a binomial distribution. Okay, so maknanya ni kita punya mean lah, mean and variance of the binomial distribution. Sebab kita ada total distribution ada 3 dalam chapter 8 ni. So each distribution tu dia ada formula sendirilah untuk mean and variance dia. Okay, so ni untuk means and variance for the binomial distribution.
Madam,
Ya,
saya nak tanya boleh?
ya.
Yang Mida cakap X dengan P tadi tu kan, maksudnya kalau X kita tu fail, P kita pun kita ambil yang fail lah.
Macam mana? Kalau X macam mana?
Kalau X kita contoh macam number of students that fail.
Okay.
So P kita ambil probability of fail students lah.
Betul. Dia mesti tally. Macam mana?
So bila P fail, Q yang success lah, yang pass.
Betul.
Okay.
Sebab tu dia bukan semestinya, sebab tu walaupun dia kata P tu sebenarnya probability sukses, tapi dia bukan semua untuk yang sukses. Okay, dia refer pada you punya X.
Okay, Madam.
Sebab tu kalau you nak buat, dia senang you tulis dulu apa X dia. Apa probability yang you nak tu kan. So yang tu dia akan refer you punya P. So automatic P dia akan refer pada you punya X. Okay.
Okay, Madam. Thank you.
Sebab sudah pun biasa di-confuse betul sebab dia ingat macam untuk yang pass tu mesti yang sukses mesti semua yang pass. Okay, dia boleh jadi yang fail juga. Okay.
Madam.
Ya.
Kalau soalan bagi yang pass ataupun yang soalan bagi yang fail, tapi tiba-tiba dekat contoh A tu dia tanya yang fail pula. So kita kena terbalikkan ke macam mana?
Maknanya dia bagi yang pass, lepas tu tiba dia nak cari yang fail, maknanya probability yang fail. So you kena terbalikkan pula lah. Betul.
Maksudnya yang daripada soalan tu punya Q jadi untuk A tu jadi P dia.
Betul.
Okay, Madam. Thank you.
Sorry, kita okay, so tadi kita dah masuk you punya variance, standard deviations and you punya variance. Okay. So expected value. Okay, so yang ni. Expectations and variance of a binomial distribution. Okay. So for binomial distribution, expectation ni you punya mean lah, mean and variance of a binomial distribution. Okay, formula for mean you have NP and for variance is NPQ. So you kena hafal lah, you do formula ni for mean and variance for binomial. Okay, so you can refer to example 3. Okay, so example 3, dia nak what is the expected number. So maknanya nak you punya mean dengan calculate standard deviation. So calculate the standard deviation, you kena calculate variance dulu. So after calculate variance, you setkan variance, then you can find the standard deviation. Okay, so macam biasa you kena state what is the x. Okay, so you punya x tu is refer to the number of rows. Okay, so you punya n is 50. Okay, so ni you punya n dia 50. So P is equal to 3/5. So P ni refer to you punya x. Okay, and Q is equal to 2/5. Okay, so x distribute with binomial 50 and 3/5. So you need to find EX. So EX formula dia is NP. So substitute je lah. And dia with 50 and P is 3/5. Okay, and you have 30. Okay, next we need to find the standard deviation. So standard deviation formula is NPQ. Okay, so you have NPQ and you multiply. Okay, 50 times 3/5 times with the Q is 2/5. Okay, and you have 12. So to find standard deviation, set 12 is equal to 3.4641. Okay. Ini for example 3. So ni pun ada recorded video. So boleh refer juga. Okay, next try me example 4. Okay, so distributions X distribute with binomial and P has mean 60. So mean 60 is EX. So equal to 60 and variance 24. So you have variance X is equal to 24. So find the values of N and P. Okay, so you have N there. Okay, so formula for mean. Okay, you have EX is equal to NP. So EX sudah bagi is equal to 60. So equal to NP. Okay, next we have variance. So variance X is equal to NPQ. So variance sudah bagi is 24 equal to NPQ. Okay, so kita nak calculate what is the N and P. So from equation yang first, so ini you boleh consider as equation 1, yang ni equation 2. So you boleh terus substitute, this is simultaneous equation. So substitute 1 in 2. So kalau saya substitute 1 in 2, you have 24 equal to NP ni, saya substitute dengan 60 Q. So you will get value Q. So Q is equal to 2/5. Okay, so you dapat Q of equal to 2/5. Next, you can find P. Okay, so to calculate P, P is 1 minus Q. So equal to 1 minus 2/5. And you get 3/5. So you dapat P is equal to 3/5. Next, you can find N. So you boleh substitute lah. Into 1 or substitute into 2. Into equation 1 or into equation 2. Okay, so for example, saya substitute P tu into equation 1. So from 1, we have NP equal to 60. So N, substitute P with 3/5 equal to 60. And you have N is equal to 100. Okay, so you dapat N equal to 100 and P is equal to 3/5. Okay, so ini for example 4 for binomial distribution. Okay, so kita dah habis for binomial distribution. Ada soalan tak? Tak ada. Okay, so saya nak sambung sikit Poisson distribution. Okay, so ni still discrete distribution. So kalau Poisson distribution ni, okay, dia akan bagi you in terms of interval. Okay, interval lepas tu dia akan bagi you punya mean lah. Sebab you nak calculate using Poisson distribution, dia mesti ada mean. Okay, so you punya properties dia describe occurrence over an interval. So interval tu tak kisahlah dia akan bagi you in 1 hour or dalam bentuk length ke. Okay, lepas tu you ada number 2, dia range dia between 0 to infinity. So dia must be independent. Ni sama macam tadi lah untuk yang binomial, dia must be independent. Lepas tu the expected number ni ataupun you punya means tu must constant. Okay, throughout the experiment. Okay, ni penting makna you kena tengok you punya mean tu. Okay, lepas tu you punya examples. So events which follow a Poisson distribution. Okay, so kalau you tengok semua example ni dia bagi dalam bentuk interval. Okay, contoh dia kata numbers of car visiting a service station. Okay, dia bagi in 1/2. Okay, kalau untuk binomial biasa dia kata number of car je visiting a service station. Okay, tapi untuk Poisson dia akan tambah sikit lah. Dia akan bagi you in terms of range tu. Lepas tu yang ni pun sama, the number of loss in a given length of material. So dia bagi you punya interval. For number 3 pun sama, dia bagi given minute. So given minute ni makna in 1 minute. Okay, so the number of cases of a rare blood disease. Okay, you ada 10,000. Okay, lepas tu last number of bacteria per liter. Ini pun sama, dia bagi in terms of interval. Okay, and next for formula of the Poisson distribution. Okay, so you have E exponent to the power of a negative lambda. So lambda refer to the mean. Mean and times with the lambda x over with x factorial. So kalau kita tengok x dia is start with 0, dia until infinity. Dia tak ada limit for the x. Okay, dia kalau you compare with the binomial x dia ada limit. Okay, so therefore the x, the distribution of the Poisson distribution can be written as, so in terms of this one. Okay, you ada lambda. Okay, so you can refer to example 5. Okay, so x distribute with Poisson 1.3. So ni Poisson 1.3. So you have lambda is equal to 1.3. So for A, we need to have probability x is equal to 3. X equal to 3, substitute dalam formula for Poisson distribution. Kalau formula dia kita ada E negative lambda times with lambda x over with x factorial. Okay, so exponent negative lambda kita ada 1.3 and we have 1.3 and x is 3, so over with 3 factorial. Okay, so you calculate using calculator and you have 0.0998. Okay, so kalau greater than 1 for B. So probability of x greater and equal to 1. So you nak calculate probability of x greater and equal to 1. Next you will have x equal to 1 plus with probability x is equal to 2. Dia until probability x equal to, dia tak ada limit maknanya dia sampai infinity. Okay, maknanya nak senang, you boleh calculate, tukar reverse balik, or so kita you pakai minus lah, maknanya 1 the whole probability minus with the probability x is equal to 0. So you kena minus mana yang probability yang you tak nak so sebab kita nak start from x equal to 1, so you kena minus dengan 0. So nanti substitute je 1 minus E negative 1.3, so you have 1.3 power 0 over with 0 factorial. Okay, and answer is equal to 0.7275. Okay, so ni answer, ni for example 5. And next, example 5 ni sama dia macam tadi, dia bagi direct Dia bagi direct in terms of distribution. Kalau you refer to example 6, dia bagi in terms of application. Okay, so kalau untuk amplification ni you kena hati-hatilah, you kena tengok you punya interval tu. Okay, so kalau you tengok example 6, dia bagi average number of cars passing a speed camera in 1 hour. So you punya average tu dia kata, okay, so dia punya cars tu is 6. So 6 ni refer to the 1 hour. Okay, so dia nak calculate what is the probability that 7 cars passing the camera will be speeding in the next 2 hours. So dia nak in 2 hours. Okay, so you boleh state kan you punya new random variables. Okay, so sekarang ni saya state balik you punya X. So X refer to the number of cars in 2 hours. So the number of speeding cars. Okay, number of speeding cars in 2 hours. Okay, so you kena state the new lambda. Okay, so you punya lambda mesti referkan you punya X. Dia sama macam binomial, you punya P tu dia mesti refer pada X. So untuk Poisson distribution, you punya lambda tu dia mesti refer pada X. Sebab tu binomial ke Poisson, you mesti tulis dulu you punya X tu apa. Okay, so sekarang X tu dia nak in 2 hours. Yang dia bagi 6 ni in 1 hour. So kalau in 2 hours maknanya you kena multiply by 2 lah. Okay, so 6 times with 2. So you will have 12. Okay, and you get, okay, so you calculate lah. Dia nak X is equal to 7. Okay, so probability X is equal to 7. Okay, so equal to, you substitute formula for the Poisson distribution. So E negative 12 times with 12 to the power of the 7 over with 7 factorial. Okay, and you get the answer di berapa. Okay, so kalau kat sini answer dia is equal to 0.0437. Okay, so kalau untuk yang B. Okay, so kalau yang B dia nak in the next 1.5 pula. So kalau yang B, contoh saya assume Y. So Y is equal to number of speeding car in 1.5 hours. Okay, so you kena state the new lambda lagi sekali. Okay, so kalau lambda tadi dia bagi in terms of 6 ni dalam 1 hour. So sekarang 1.5 minus 6, you multiply with 1.5. Okay, and you will get 9. Okay, so baru you boleh calculate at least 2. So ni saya assume SY, you nak assume any variables lain pun boleh. So tadi saya dah assume yang first ni, you punya random variable dia X. So untuk yang second ni, saya tukarlah, saya assume dia SY pula. Okay, so you have 9. Lepas tu baru you boleh proceed at least 2. So kalau at least 2, you punya probability of X, so ni probability of Y, dia must be greater and equal to 2. Sebab dia nak sekurang-kurang itu. Okay, so dia also equal to probability of Y equal to 2 plus with probability of Y equal to 3 until probability of Y equal to infinity. Okay, so you kita calculate reverse balik lah. So 1 minus kan dengan probability of Y equal to 0 minus probability of Y equal to 1. Okay, so nanti substitute formula for Poisson distribution in Y equal to 0 and Y equal to 1. Okay, and you calculate using calculator, answer is equal to 0.998. Okay, so ini example 6. So you boleh refer juga recorded video pun ada for example 6 ni. Okay, so kita stop dulu kat sini. Nanti expectation and variance of Poisson distribution tu kita akan continue esok. Okay, ada soalan? Tak ada?
Tak ada, madam.
Okay, so tu je untuk hari ni. Thank you class.
Thank you,
Thank you,
madam.
madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.